Yes, I mean, agriculture revolution has indeed changed lives of a lot of people. With sustainable development of agriculture, we can have food security for each and everyone. As you said, geospatial data sciences can definitely help in this, from identifying the cropping pattern to agriculture mitigation because of climate change. This all can be achieved with the help of GIS data and modeling. So, I am actually working on SDG 7, which is clean and reliable energy for all. Energy, water, and food nexus is very much interconnected. And even in my personal work, I use Professor Wu's packages on Google Earth Engine when it comes to linking energy with agriculture and land use land cover. Therefore, I really urge you all to learn as much as you can learn from him. You can also watch his mapping videos on YouTube channel. I'll paste the link shortly here, and I'll also paste the link for the GEE folder right now. But a little bit about Professor Wu. Dr. Wu is assistant professor in Department of Geography at University of Tennessee, Knoxville. His research interests include geographical information science, remote sensing, and environment modeling. Dr. Wu is an advocate of open science reproducible research. He has developed several open source packages for advanced geospatial analytics like Gmap, Map. You can, even go and see his projects on GitHub. I'll share the link of his GitHub link and YouTube link. You can go through it. Over to you, Dr. Wu.
Thank you, Akensa, for the introduction. Can you hear me?
Yes.
Let me the light.
Yes, can, sir.
Okay, let me share my screen. Can you see my screen?
Yes, we can.
Okay.
Yes.
And so today we're going to go through some of the examples how you can use Google Earth Engine and cloud computing to do crop mapping. And I sent the link in the chat over there. You can click the link, or you can just go to the gmap.org website. And then from there, on the left side, workshops. The last one, crop mapping 2022. So if you click this one, you should be able to open. And so this is all the examples are based on Google Earth Engine. So make sure that you have a Google Earth Engine account. If you don't, you can just watch. You can apply later, and then you'll be able to run 3 examples. So I try to make it as simple as possible, but also reproducible. So you'll be able to follow through and go through the examples. And I'm not sure how many of you have used Google Earth Engine before. So for those of you that have not used before, you can think about Google Earth Engine just like a streaming services. Just like you're watching movies, traditionally you're having a DVD, you download data, download DVD, or you buy a DVD and then you load into the DVD ROM and then you play the movie. But now you can simply go online, Netflix, Amazon Prime, those kind of streaming services. You just need to watch a movie and then just do a typing. You will be able to get access to that. Since this is not like a Earth Engine introduction, so I don't have time to cover that, but I just want to let you know that it's just like a cloud computing environment allows you to actually access data and then visualize data and then also do all kind of computation. So once you go to the link, upper left here, you should see 2 icons, open in Google Colab or launch Binder. So you can use either one. You can use Google Colab or you can just right click and then open a new tab. So let me show you quickly here. This will be what it looks like. So make sure that you log into your Google account and then you should be able to go through. Again, you need to have a Google Earth Engine account before you can follow through. Otherwise, you won't be able to do that. And so before I get into the details, I would like to point you a couple links that might be useful. So the first one will be just the Google Earth Engine website. So if you click the link, it should take you to the website. So this is where you can learn more about Google Earth Engine. So we don't have time to cover, but it's a tons of information on the website. If you don't have a Google Earth Engine account, upper right corner here, sign up. If you click, and then you should be able to sign up using Gmail or your edu email address. And once you sign up, it might take a couple days to get approved. Once you have that, you can start using Google Earth Engine. So I also have a couple other here. awesome G community data set. So this is also a very nice resources that has a lot of data. So if you're doing any kind of remote sensing research, you might want to look at this one first. Also, the Google Sensing official data catalog. So you have, I think, over 70 petabytes of data. So petabyte, like 1 petabyte is 1,000 terabytes. So you have 70,000 terabyte of data at your fingertips. You don't need to download anything. You just need to know how to access the data. Then you can do all kind of analysis. Also, the Gmap website, and this is the website that you are using right now. So this is the Gmap website. You're always welcome to come back and to learn more. And I will continue to update and maintain this website. Also has a book here, a Gmap book. On the left side here, you can also click the second menu item here, book. And if you click, you should be able to see this is the book that I'm writing right now. And it's not finished yet, but it has 11 chapters. I think I roughly finished 8 chapters. So if you want, you can click. You will be able to look at all the source code. Chapter 1, I already also the source code and also the text, everything is available. So you can take a look at that. And for other chapters, you can look at the source code. And the book will be published maybe later this year or early next year. And you can follow the website to see the most updated, but all the source codes are available from there. And so what we're going to cover here today, it will be just one simple application. So on the left side here, lane cover change. I think I'm not posted yet here, but you'll be one of the examples that I'll be using in the book. So what we cover here today will be in the book. So you're welcome to go through that. And definitely this is not something I can cover within 1 hour. This takes maybe a whole semester. So many hours to actually go through all of those. So if you want to learn more about Google Sensing and Gmap and Python, I highly recommend that you go to this book and you can download the notebook and then you'll be able to go through all of those. Okay, so this is about some of the links, and you're also welcome to check out my YouTube channel. So I publish lots of Google Sensing and other mapping videos. You can check out the YouTube channel, and you can subscribe if you want to receive updates about the tutorial. So, okay, so that's all about the links. And then, so next, I'm going to quickly go to the notebook. So showing you how to get started, and you will be able to have all the results. Maybe let me show you some of the outputs first. So you will be able to see, for example, you can scroll down, you can create some maps. You can, these are all interactive. And you can create, for example, bar plot, pie chart, and you can see these are all interactive. You can, for example, click one, you're going to hide one classes, and maps, tables, figures, and also something like this. You can also have split panel map, so you can compare the differences of different data layers. So I'm going to show you how to actually extract cropland for multiple years at the global scale, or at just for Africa, for example. So you can see this is what we are going to produce after you finish this workshop. So you can take a look, right? You can different countries. You can see how the cropland area is increasing, decreasing, and everything just a couple lines of code. You will be able to do that. You don't need to download anything to your computer, and you will be able to access or visualize data at the global scale or continental scale. So, for example, see the changes of different data layers, and you can zoom in, you can zoom out, you can see something like this. This one might not work very well on Google Colab, but you can also download the notebook to run that on your computer, and similarly like this, right? So hope this give you some like flavor. You can expect what you're going to produce after this. And so next, let's go through the notebook example. So someone is asking about the link. I'm just saying over there. So and if you open in Google Colab on the left side here, you can see the table of contents, right? So upper left corner here, this is where you're seeing on the source code. So this is very practical examples. You need to make sure that you have the Google Sensing account, and then you just need to click through. If you are familiar with Google Sensing, perfect. If not, you will still be able to follow through. And so when you first open this one, you need to install the package called Gmap. Okay, so you can either remove the pound sign at the beginning, or you can just use control slash on your keyboard, and you become a code block, and then just click the run cell and run anyway. So this will actually install the Gmap package, and it might take 1 minute or two, and after it's installed, then we can just restart. Then you will be able to follow through. So again, just click this one, install all the packages, then we'll be ready to go. If you are on your local computer, you don't need to install every time. After you set up your environment, you should be able to do it. Again, if you want to learn more, you can go to the book website, and then from there you should be able to learn how to install the packages, how to set it up on your computer. And since we are limited on time, I'm not going to go through all the steps, but you can watch that afterwards. Okay, so it already finished the installation. At the end of the code block here, you will see some red color, and what you need to do is just to restart the runtime. So you can just click the button, restart, yes, okay, and then you are good to go. There are too much text here. Clear the output, and here you go, it's done. And then you can start import the library. So you just click the import EE Google Earth Engine and also Gmap. It might take a couple seconds the first time, and if you see this green check mark, that means you are good to go. Then let me execute this one first, just to show you, and then I will introduce the data set later. So if you click this one, it's going to ask you, okay, you need to authenticate Google Earth Engine. So basically, every time you're using that, you need to authenticate your connection to Google Earth Engine, because you are getting the data from Google Earth Engine, and also do the analysis. So make sure that you here you click this link, and then from there you need to sign up, set up your account, and generate a token, and then select your account and click allow. So this is a little bit tedious, but you need to do that every time you are using Google Colab. If you're doing on your local computer, you just need to do that once. And once you get the code, Control V, copy, and Control V here, press enter, then you should be good to go. You will see the map, right? So if you can see this one, that means you have been successfully authenticated, and then you will be able to use Google Earth Engine forward. Otherwise, either you don't have a Google Earth Engine account, or you're not doing it correctly. Again, all the details are on this chapter 1 here, Earth Engine authentication. I have all the steps are recorded, and you can just follow the steps to authenticate that on your account. Otherwise, you want to do that. So from now on, I'm going to use my local Jupyter notebook. So rather than using Google Colab, so once you set up the environment, you can open that using Jupyter Lab or Jupyter Notebook. So on the left side here, similarly, you will find the hamburger sign here, and you will see the kind of a table of contents. So in this workshop, I'm going to introduce 3 data sets. The European Space Agency WorldCover, 10-meter resolution, just one time period, so 2020, and the Esri global land cover data set. So this one has a time series from 2017 to 2021. So you get 5 time periods, 2017, 18, 19, 20, 21. So you have 5 time periods of global land cover, also at 10-meter resolution. And the last one is the dynamic world land cover data set. So that one, you basically near real time. So every Sentinel-2 imagery, 10-meter resolution is being classified. So this one you can create, for example, weekly land cover, monthly land cover, or annual land cover. So it depends on your applications. And you will be able to create those kind of time series just using a couple lines of code. And since this is specific for African countries, so I'm going to show you how you can actually extract data for your region of interest, and then you can analyze all kind of data. So earlier I already showed you some of the kind of results, but I'm going to clear the output and then we can start from scratch. So I'm going to restart kernel and clear all the output. So now everything is clean. So first of all, you need to import the libraries. And so I'm going to import Google Earth Engine and Gmap. So for those of you who are not familiar with Gmap, so it's a Python package that I developed built on top of Google Earth Engine, but makes it so much easier for you to analyze data and also do visualization. And so the first data set we're going to cover is the ESA WorldCover 10-meter resolution. You can see the description in here. You can go to the website to learn more if you want. So it's a 10-meter resolution based on Sentinel-1 SAR data and also Sentinel-2 optical data. And so it provides a couple of ways for you to access the data. And the first one I'm going to show you here is using web map services. So web map services, basically, you can think about Google Map, Google Satellite. It's a web map services. So you are streaming the data to your computer using just a browser, using just a URL, and you don't need to download any data. It's very much similar in here. And let me execute this one first, just to show you what the output look like. So you will see something like this. And let me quickly go through the source code, right? Gmap.map, you create an interactive map, and then this will be the URL. So this will be the web map services. Think about Google Map. Let's take Google Map URL. And then we have a couple of layers. So the first one, TCC means true color composite. FCC is false color composite. And the WorldCover 2020 map, this one is the lane cover classification. And so these are basically the URL and also the name of the layer. After that, you can add the layer to the map, right? So add the WMS layer, and this will be the URL of the web services. And this will be the layer that you want to add. And you can also choose a name for the layer, also attribution, right? So add the true color, first color, and also the lane cover. The last line here is the add the legend. So the legend is lower right corner here is this one. So basically we create a map, we add a bunch of data layers, and we also add the legend. That's it. And everything is just a couple lines code. And you can zoom in, you can zoom out. You will see when you zoom in, it's going to show you more data. So this is just like streaming data. You don't need to download anything. Just like you are looking at Google Map or Google Earth, but you will have a lot more things to do. You have a lot more control. Upper right corner here, you have a toolbar. So if you click, you can also there are a bunch of tools in here. We don't have time to cover all of them, but if you click the sandwich icon, the layers, and from there, you will be able to see the layers, right? So earlier we add the true color, the first color, and also the classification. You can turn the layer on and off, right? So now you see it's gone, and the first color composite and also the true color composite. You might want to zoom out a little bit to see like the full picture. So this is global Sentinel-2 imagery at the global scale, 10-meter resolution for 2020, right? So you are seeing the true color, and let's turn on the first color and also the classification, right? So these are the three data layers. You can also use the slider bar. So for example, you can change the opacity of the layer, right? So if you need, you can compare different layers. So it's pretty easy, and just add layers, and then you can change the layer opacity if you want. So this is how you can load the data. Keep in mind, this one is using the web map services. Basically, you're just visualizing the data. You cannot do any analysis. So this is just like you are viewing Google satellite imagery. It's just a web map services. You don't get the original, the raw data. You don't get the GOT. You don't get the raw data. So it's only for visualization. If you want to do analysis, and this is what we're going to cover later, is that we're going to add data from Google's engine. But the difference is that you can do analysis. You can extract your region of interest. You can do some statistics if you want. Okay. So, and that's the first example. So the second one, we're going to use Google's engine. I also have the link in here. I think I have a typo here. So be ESA WorldCover in the Earth Engine Data Catalog. So if you click the link, it will take you to the website. So here you can see more information about that. You can see the description. You can also see some sample code. You will also see this one here, Earth Engine snippet. So this one is the unique ID. So we can think about every data set in the Google Earth Engine data catalog has a unique ID. Once you know the ID, you can load the data. Think about when you're watching movies online, your streaming service, streaming. You just need to know the name of the movie, and then you type into your search bar the database. You'll be able to search the movie, and then you can watch that. Very similar idea. Once you get the ID, I can load the data to the map, and then I can do some analysis. Pretty similar to what we used earlier, right? And then you will see the legend, you will see the data layer. Now this one is Google Earth Engine data. So you can use that for analysis. You can extract data. You can do all kind of statistical analysis. So similarly to what I showed you earlier, you can use the layer control here. So you can change the layer. See here. You can change the opacity. You can turn the layer on and off, and you can also turn off the data layer. So the second one here, Google Satellite, is this line here, add base map. So I'm adding this base map so that you can compare the land cover data set with the base map. And then you can zoom in, you can zoom out. For example, here, you can zoom to a specific location. And if you want, you can do this. So you can see how good is the classification. You can also check the pixel value. So for example, here, you can click this one. The first two here is called inspector. So if you click this one, and then you click on the map, upper right corner here, it's going to show you the data. So for example, this is the pixel value, 80, right? So 80, if you look at this one here, it's open water. If you click on the red color, it's going to show you 50, right? The view up. So this is how you can basically check the pixel values if needed, and everything is basically in the Google Earth Engine cloud. If you need to get something, you will need to take your mouse, get the coordinates, and then use that coordinate. So this is how you can add the data. You can check the pixel values. Next, I'm going to show you how you can create some plots. And so the first one here is going to use a histogram. So keep it in mind here. Histogram is because this is a land cover classification data, and it has different categories, right? Different classes. And one simple question I can ask is, for example, how much is the urban area? How much is the agricultural area, right? Basically every classes. And you can just use one line of code here, image histogram, and then you pass in the data set. You also specify what the scale you're going to use, and 1,000 basically means 1,000 meters, so 1 kilometer. Let me generate the results here so they can see the outcome, right? So we have 10 classes. Each class has a certain area, right? So and then you can see the axis, y axis. So the y means area, right? So 1,000 basically every pixel is 1 kilometer, and 1,000 meter by 1,000 meter, it will be 1 kilometer. So you can see here the majority of the land cover will be the first category. So number 10, trees, right? So trees has the most coverage at the global scale. So this is at the global scale. Think about if you have to download the data, this is many gigabytes. So it's going to take you many hours or even days to download the data, and then you need to analyze the data. But now, just one line of code, and then you can directly get the result directly, and you can customize if you want. So if you directly want the output, you can run this line, but sometimes you might want to generate a table. So the second one here is you passing the return df, so basically return as a data frame, and then from there you will see 10 all the way to 10 to 100, right? So this will be the value. The value means the total area in square kilometer, right? So once you have this data table, you can do further analysis, right? You can do create other plots if you want. So let me show you here quickly, go through what do I mean, right? So I can with this table I can add another column, right? So now is this just the key 10, basically the class values. I can add the label, right? So I can attach the label, and now you can see this is using right now much better because you have the label, you also have the area, and with that you can, for example, calculate the total area, right? 217 million square kilometer, right? So the total land cover area of this data set. And similarly, you can create some other charts. So this one will be more intuitive than the first one. So the first one, you only have like numbers, something like that. But now you can see the class, right? So 10, 30. So this is the global land cover data. Basically the trends, you can see trees has the most land cover area, over 6 million square kilometer. You also have grassland, you also have open water all the way to the end. So built up area is actually pretty tiny. And cropland is number 40. So 40 you see here, roughly 16 million square kilometer at the global scale. So this is how you can quickly create this kind of interactive plot. You can zoom in, to a certain area, and then you can just reset. So this is, everything is interactive and very easy to create. This is the bar plot. You can also create a pie chart. So the pie chart means I want to figure out, for example, what's the percentage of cropland at the global scale. Then you can just create a pie chart, specify which column you want to use for the label. So we have the label column. We also have the values column, and you just execute. You will be able to create this kind of nice pie chart directly. And as you can see, right, trees accounts for 28%, and open water, so a sparse vegetation, cropland accounts for 7.6% at the global scale, right? On the right here, you can see the legend. So if you don't want a specific class, you can click that. The plot will be updated interactively. So you will see here, it becomes hidden. That means it's taken out, right? So you can click, you come back again. They say, I want to take out cropland. You can take it out, and you can play with that. Pretty nice. So this is how you can create the plots very, very easily. And so earlier, what I showed you is at the global scale. And for now, for example, I just want to look at cropland or land cover in Africa. I'm going to show you how to do that. So let me execute this one first. This couple lines of code basically adds basically country boundaries. The first one is the country. So you see all the black color. Let me turn off this one, so it might be easier, right? So you can see the black color outlines. So those are the country swap files, the vector data. And then I filter that to add just countries in Africa. And then this is how I'm going to visualize that. Add the 2 data layers to the map. That's it. And so let me go back to here. This is Africa, right? And so let's say I just want to analyze land cover data in Africa. I want to figure out what's the cropland area, what's other data type. And the first you need to basically figure out your region of interest, and then you can crop to that. So next, I'm going to show you how you can extract data for Africa, right? So you can say this is the ESA land cover and equal to 40, right? So if you recall here, cropland 40, right? So you can just, if this equal to 40, that means it's cropland. And then I'm going to just click to Africa area and then mask out other area. And then I can add that one to the map. So take a look. Right now it's gone. You will see this one here. The pink color, this one is the cropland in Africa, in all the countries. So you can see, right? You can zoom in, you can zoom out. You can also turn on the satellite data layers and cropland, right? And you can zoom in, you can zoom out, you can see where are they. And again, so land cover data set is just, it depends on the time, depends on the year. It might not be always accurate. So, but it will give you some basic information about where they are, and you can always zoom in to see more details, see if this is accurate or not. But at least now you can extract land cover data, for example, for Africa, just one line of code, and then you can get the data. You don't need to download the data. So next, let me show you how you can analyze the data. So one thing we can do is to analyze, for example, what's the cropland area in every African countries, right? So for example, Nigeria, Ethiopia, I want to figure out, for example, how much cropland in each one. So over there, you can use the zonal statistics. Zonal statistics allow you to calculate statistics based on each region, right? So this is the cropland data layer, and this is the African countries, right? You have a lot of polygons, and you can specify output is a CSV or is a swap file, and you can also specify the statistical type. Sum means you're going to calculate the total area, and we're going to use the scale. So you can specify this one. The original data set is 10-meter resolution, so it's pretty fine resolution, but it might be a little bit slow if you set a small number. So the scale, I think, for this exercise, we want to use 1,000 meter, basically 1 kilometer. And take a look, pretty quick. Now you have the data downloaded to your computer. So ESA Cropland CSV, and if you double click, here is where you can see the data set, right? So you can see the total sum, and also all the attributes in the original polygons are also here. And with that, then you can do some create some bar plot. For example, you can also look at the data table here directly within Jupyter Notebook. So you can see, for example, I just show you the 5 rows of the CSV, right? You have the country, you have the total area in square kilometer, and then you can similarly create a bar plot, right? And from here, take a look. You will see the cropland area in African countries for just 2020 using the European Space Agency land cover data, and you can zoom in if you want. Right. So, by the way, this one here only shows you the largest 30 countries in terms of a cropland area. If you don't specify, you will plot all of them. So if it's removed, you see these are all the countries. So it might be, some of those might be pretty tiny, and it's based on the descending order. So if you want, you can specify how many. For example, I just want the top 20, and then you can change the number. It will show you the top 20 or top 30, and the X label, right? This where here country, area, and there are also other parameters you can customize. Shift tab. So there are a bunch of others. If you want, you can do that. Besides that, you can also create a pie chart to see, for example, what's the composition of cropland area in Africa. So take a look here. Nigeria, 18%. And so because we only have the maximum 20 countries, so the remaining country will be classified as other country. So if you see here, there's other, the second one is others, right? Basically the remaining after 20, the OB group is one class, one category. So it's 12%. And then Ethiopia, if you don't want to see the others, you can click this one. It's going to hide that one. So now you see all the countries. You can create this one pretty nicely. And if you want, you can save this one as a PNG to your computer if needed. So this is how you can analyze cropland data layer in Africa using the European Space Agency land cover data set, just a couple lines of code, right? So play with that. I only show you some like simple one, but the next one I'm going to show you is that you can actually analyze the time series. So because the European Space Agency only has one time period, 2020, you can certainly have more. So the Esri global land cover. So this one has 5 time periods. So it's 2017 all the way to 2021. So we have 5 time periods of land cover data. And let me execute just to show you what it looks like. So again, we create an interactive map, and then we load the data. So this one is not from the Google Earth Engine data catalog. It's actually from the awesome community data set. So pretty new. So this one was just available, I think, maybe a couple of weeks ago. And the good thing about this, it has multiple data set, multiple time periods, right? And visualization, add the data to the map, and then add the legend. So on the right here, lower right corner, you will see the legend. Keep that in mind. the legend or the color is different from the European Space Agency, because every organization produce a data set. They might not always be the same, and they use different algorithms. They use different classification schemes, but you can always zoom in. For example, use the data layer here. Take a look, right? 2017, 18, 19, all the way to 2021, and you can turn all the data layer off, and then just turn in one of those, right? So 2017, and then you can change the opacity. Similarly, you can change 2018 if you want. So I'm going to zoom in here, right, to a specific location. So the yellow color here is the cropland area. The red color is the build-up area. And again, you can turn this one. Take a look. And so the Esri land cover is pretty coarse resolution. So basically it aggregates, so it might not be very accurate, because from what you see here, these are the red color all urban view area, but I think it's a little bit overestimated. And the yellow color is the cropland area, and also the green one is the tree area. So take a look. And you can compare multiple data layers if you want. So again, you have 5 time periods. Sometimes it'll be more convenient if you can have a kind of a split panel map that allows you to compare data side by side. So I'm going to put all the 5 data layers together as an image collection. And then I'm going to create something like this. Let me show you here. Right, on the left side, you have a drop-down list. On the right side, you also have a drop-down list. So in this way, you can compare data from 2 different years. And let me zoom in here just to show you the differences. Right. Can you see the differences? You might need to look into that closely. So it certainly have some changes in here, right? So you can see the urban area grows a little bit in those 4 years. But whether it's true or not, it's hard to tell. You need to have some knowledge about the area, and also look into the data set being used to do the classification. It might not always be accurate. But this is what the data provides. So I'm going to show you that if you want to change other year, for example, I can change to 2019. You will see the data layer change. I can change to 2020, and it changes right away in near real time. So we can compare the 2 different data layers together. So this one allows you to quickly compare different data layers simultaneously. Next, I'm going to show you here how you can extract the cropland area for African country. So pretty similar here. I'm going to add the country boundary, and then I'm going to extract a cropland area for those 5 time periods. Again, these are using the map function. So we don't have time to go through the details, but under the hood, basically, for every image, I'm going to extract the cropland area, and then I'm going to do some statistics. So take a look here. Now you see this, we have the cropland area. And if you want, you can, this is just the first one. So the cropland area for 2017, right? So the brown color here, this will be the cropland area. And once you have that, you can do some statistics. So we have 5 time periods of our cropland area. And so this is basically a time series, right? So from 2017 all the way to 2021. Then you can do zonal statistics. So this will be the cropland time series. And we want to do that for African countries. And this is the output of the data. Statistical type is sum, basically calculate the total area and also the scale. So take a look, only a couple seconds. And on the left side here, you have the Esri cropland, right? So look at this table, pretty nice, right? 2017, 18, 19, 20, 21. So you have the cropland area for every African countries. And then you can do some interesting plots just to visualize this data table. So let me go back to this one here. I'm going to read the data table and just show you the first 5 lines of records. and then we can create a bar plot, right? We're going to use this data frame. The X, we're going to use the country column, and the Y means is years, means you can have multiple columns. So in this case, we have 5 columns data, but you have more, you can just change something in here, or you can directly provide the parameter. Maximum rows, that means we only want the maximum 20 countries. And take a look. So now you have this one, right? So every country from 2017 to 2021, and you can see the changes of those 5 countries. On the right here, show you the legend, right? Again, you can zoom in to see more details and see how the croplands for all the countries. And again, on the right here, you can click specific year to hide that if you want. So for example, I just want to look at 2020 and 2021. You can do that easily, right? And you can also export that if needed. So this is how you can analyze the time series. If you're interested in the changes of agricultural area or cropland area in a certain region at the global scale or continental scale, you can do it easily. Just couple lines of code, then you can get the results, right? Besides, you can do a pie chart, right? They say for I want to look at the 2020, the land cover, the cropland area for all the countries in Africa. You can see the data frame, the name, values, maximum 20 countries, and the height is basically how big is the pie chart, right? So you can see move the changes, Ethiopia, South Africa, right, and then other countries. All right, so this is how you can analyze the time series. Next one, I'm going to show you how you can analyze the cropland gain and loss, because once you have the time series, you can figure out how it's changing. Is it getting more cropland area, or is it getting less, or is it increasing, or is it decreasing, right? So this one here, this example shows you how to compare the changes between 2017 and 2021, because 2017 is the first year that we have the data set, and equal to 5. 5 basically is the cropland, right? So if you see the cropland here, equal values to 5, and take a look at this one, equal to 5, and then click the area. So cropland gain means, okay, in 2017 it is not cropland, but in 2021 it is cropland. Vice versa, if it is loss, that means in 2017 it is agriculture cropland, but in 2021 it's no longer cropland. So this is basically the condition I used to figure out the changes, and then you can add the 2 data layers to the map. So let me show you here, just to see the changes. And if you zoom in maybe to here, African countries, let me see, I zoom in here in Uganda and Kenya. So the yellow color means agricultural gain. That means it's increase. Red color means agricultural loss. That means it's decreasing. So you can see, for example, the changes between 2017 and 2021. Again, they might not always be accurate, but I'm just using the data to showcase the area. So you can see, for example, red color is the loss, and the yellow color is the gain, right? So you can zoom in to see whether it's real or it's not real, because it's using the machine learning. We might not always consider the contingency of the data set. But once you have this, you can also analyze. For example, you want to figure out which African countries lost most agriculture, or which African country get the highest increase in cropland area, right? Similarly, you can use the zonal statistics. The first one we are analyzing here is the cropland gain, and we're going to do the countries. Oh, this is at the global scale, not just for African countries. So, but you can, if you want, you just pass in Africa, you will be able to do that for Africa. So, and then specify the output, CSV, again, the type, and also the area, and take a look and generate, and you can display the table. This shows you, for example, for all the country at the global scale, and this is the column we're going to plot. The sum is the total cropland gain. So basically the increase and the X column and the Y column. And we can create a bar chart here showing you the changes of cropland gain for all the countries around the globe, right? You can see Russia, Brazil, USA, China, India, and other countries. These are the gain. So 250,000 kilometers gain in 4 years of time. Similarly, you can also create a pie chart, right? So you can see, okay, within like 4 years time period, what's the percentage of each country the gain, right? So you can see others like 19, almost 20%, and Russia increase accounts for 11, almost 12% of the agriculture. And you can hide the other categories because we only show the top 30 countries, the countries with the most agricultural cropland gain. Similarly, you can do like loss. You can analyze loss, cropland. By the way, this is not just limited to cropland. You can analyze forest change. You can analyze land, urban area. You can analyze water. Basically, it depends on the water, the data set that you analyze. So the next one is cropland loss, right? So again, similarly, you can plot it out and just to showing you which country has the most cropland loss between 2017 to 2021. So you can see China, Russia, USA, and other countries. And again, you can zoom in, you can change the y-axis if you want, right? And again, the last one here, you can do the pie chart, right? You can see which country has the most loss. For example, 14, almost 15% in China, 8.9% in Russia and USA, right? Again, you can hide this one just to see a little bit more details. And if you need the larger one, I can change the height to maybe 700 to get a much larger pie chart. And again, everything is all interactive, so you can customize to the way you want. There are also a lot of other parameters you can customize if you want to. All right, so that's for the Esri global land cover. So 5 time periods at the global scale, and you can do whatever you want to analyze the data. The last data set I'm going to cover here is called Dynamic World Dataset. So this one was developed by Google and World Resource Institute, just released I think a couple months ago. Nice thing about this is that it classifies every Sentinel-2 imagery that has cloud coverage less than 30%. So it's very high temporal frequency compared to the Esri only have 5 time periods. So for this one, you can do it monthly, you can do it weekly, you can do it annually. You have a much temporal frequency. So again, I'm going to create a map and I'm going to specify, okay, 2021 to 2022, basically 1 year. And this is basically, okay, I want to create a mosaic of land cover for 2021 at the global scale. And take a look. Just one line of code using Gmap, you will be able to get that pretty easy. So take a look at this one, you see. And also the advantage of this data set is that it has a probability for classification. So you can create a huge rate based on the classification. So you will see, for example, this is a water body, right? In the center, it's much more likely to be classified as water. But in the edges along those pixels, the probability of being classified, basically you have more mixed pixels. Mixed pixel means it might be classified as water or it might be classified as vegetation, wetlands, and others. So the likelihood of basically the accuracy is much lower. And it's lower, you will see like a valley. So it's like a 3D, the hue shade. So it looks pretty nice. And you can, again, you can turn the data there. So this will be the original one, just the land cover classification. And this one will be with the hue shade, right? So you can see it's much better because you can see mountains, you can see flat area, you can see valleys. So this means you have more information to actually create a map like that, right? And so you can also change the data layer. So for example, I can change the base map. I can change to Google Hybrid, right? And once you have that, I can turn on the data layer just to show, right? You see it's water, right? Red color means built up area, urban area, vegetation. So pretty nicely. And you can zoom into, for example, other region of interest. But this is computation at near real time. So when you zoom out, it might take a while to actually display the data set. So because it's being computed and basically you're streaming the data to a computer. So it might not be always be instant. So if I zoom into every African country here, this is Ethiopia. It might take some time for it to load, but once it's there, you can compare the data set with the existing data layers. So for example, this is the lake, and it's not there, it's coming. It's basically it's tile by tile. So it's if the region that you have not see before, it might take a while. So now you see this is the water body and agriculture, shrubs, something like that. So you're welcome to extract, for example, cropland area at a monthly scale if you want, right? So here, pretty nicely. So the last two example is basically creating a map for you to compare the two different data layers, right? So the first one that we already cover is the European Space Agency land cover data set, 10 classes, and also the dynamic world data set. And this allows you to compare the data side by side. You might notice that the European Space Agency one is a lot more details. For example, you can see the rows and other linear features, but you're using the Google, the dynamic world data set, you see it's a lot more coarse. Basically, it's aggregated, and so you don't see a lot of details in there. But the nice thing is that you have the probability, so you can the visualization looks much better, and you also have a longer temporal frequency, weekly, monthly, depends on how you want to create. So this is how you can compare these two data sets. If you want, you can also do it. Compare the Esri land cover, right? So this is the second one and the third one that we cover, and these two are pretty much similar because they use a very similar algorithm methodologies, most deep learning and machine learning, and both are pretty close resolution. So you can see here, quite similar. Not always the same because the year, this one is 2021, and what's this? Yeah, both of them are 2021. So Esri land cover 2021, and I add the legend on the left side for the Esri one. Add the legend on the right for the dynamic world data set, and you can do the comparison. And this is how you can compare multiple land cover for your area. And then if you want, you can extract data, for example, for every car again, or for any other region of interest. You can use zonal statistics to calculate the area, and then you can do some plotting, create some nice charts for your study area. Okay, so that's pretty much about it, and you're welcome to download the notebook to run it on your multiple times, and then so this is just one simple example how you can use Google Sensing and Gmap to create visualization and visualizing data, and also do some simple analysis. A lot more information in the book here. If you click the book, you will be able to learn a whole lot more about the basics, how to get imagery, image collection, vector data, raster data, and also how to analyze data. This can take 20 hours of training of workshop, but it's only 1 hour, so that I can only cover so much. So thank you very much for attention. If you have any questions, I'll be happy to answer your questions.